Welcome to this tutorial on using Zookeeper for distributed coordination. In this video, we will explore what Zookeeper is, why it's essential for distributed systems, and how we can leverage its features for effective coordination among distributed services. So, let's dive in. First, let's start with a high-level overview of what Zookeeper is. Zookeeper is a centralized service for maintaining configuration information, naming, providing distributed synchronization, and providing group services. It's a crucial building block for distributed applications. Zookeeper's architecture is based on a hierarchical namespace, similar to a file system. This namespace is composed of nodes, which hold data and metadata. Nodes can be either ephemeral or persistent, and they can have children, allowing for a tree-like structure. Before we dive deeper, let's set up Zookeeper. Make sure you have Java installed, because Zookeeper is a Java-based application. You can download Zookeeper from the Apache Zookeeper website. Next, let's configure Zookeeper. Go to the conf directory and create a configuration file named zoo.cfg. This file will define various configuration settings for our Zookeeper instance. Open the zoo.cfg file in an editor. Here, we'll define a data directory and the tick time, which is the basic time unit of Zookeeper, in milliseconds. Now that our Zookeeper is configured, let's start the Zookeeper server. Run the following command in your terminal. Once Zookeeper is running, you can connect to it using the command line interface. Start the CLI using the following command. This will allow us to interact with our Zookeeper server. With the CLI, we can create nodes. Let's create a persistent node named /example. This node will serve as our primary coordination point. You can verify that your node has been created by listing the nodes in the root directory. Now let's explore ephemeral nodes. Ephemeral nodes are deleted when the session that created them ends. They are useful for managing resources that only need to exist while a service is connected. Let's disconnect from the Zookeeper session right now. You will see that the ephemeral node /temp node gets deleted automatically. Next, let's write a small Java program to interact with Zookeeper. For this, we need to include the Zookeeper client dependency in our project. If you're using Maven, add this to your pom.xml file. Now, let's create a new Java class named Zookeeper example. We will implement a basic Zookeeper client that connects to our Zookeeper server. In the connect method, we initialize the Zookeeper object. The constructor takes the Zookeeper address, a session timeout in milliseconds, and a watcher callback that receives events. We have defined a method, createNode, which allows us to create a persistent node at a specified path with the provided data. Let's complete our class with a main method to execute our program. In the main method, we connect to the Zookeeper server and create a node with the path /myznode. Next, let's run this program to see if this node is created successfully. After running the code, let's verify via the command line interface that our node has indeed been created. As we can see, this node /myznode is listed. Great! Now, let's discuss another important feature of Zookeeper, distributed locks. These are essential for managing resources among different distributed services. To implement distributed locking, we can create an ephemeral node to act as a lock test. If a service wants to acquire the lock, it will attempt to create this lock's node. If it succeeds, it holds the lock. The acquire lock method tries to create an ephemeral locks node. If it succeeds, it returns true, indicating that the lock is acquired. If another instance has already created this node, it returns false. Similarly, we will implement a method to release the lock by deleting the lock node once we're done with the critical section of our code. Now that we have our lock methods, you can use these methods to synchronize access to a shared resource in a distributed application. This is a powerful feature of Zookeeper that enables coordination. In summary, Zookeeper provides a robust set of features for handling distributed coordination. Today, we learned about creating nodes, ephemeral nodes, and implementing distributed locks in Java. As a final demonstration, let's run a sample scenario where multiple clients try to acquire a lock simultaneously. We'll simulate this with multiple Java threads. In the simulate locking method, we create multiple threads that attempt to acquire the lock. You can observe how Zookeeper ensures that only one thread holds the lock at a time, demonstrating effective distributed coordination. To run this simulation, simply call Simulate Locking from your main method after establishing a connection to Zookeeper. That's a wrap on today's tutorial. We learned the fundamentals of Zookeeper and how to use it for distributed coordination with Java. Be sure to explore Zookeeper's features further and consider how you can apply them to your own projects. Thank you for watching. If you found this tutorial helpful, please like, subscribe, and hit the notification bell to stay updated with my latest content.